Hey everybody, this is Larry. This is me going over Q3 of the Leetcode weekly contest 215. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's Q3 minimum operations to reduce x to 0. So this one, this one's kind of hard. It's tricky. You have to kind of think about how to do this in a brute force kind of way, but in a way that lets you do it efficiently, right? Because the key thing to know is that n is 10 to the 5th. So if you do something n squared, which is the naive way, it's gonna be too slow. So the thing is that this problem becomes a good practice in prefix sum, which I have a video on, by the way, so you can check that out. And also suffix sum, right? The invariant, and I'm gonna show the code real quick. The invariant that I would try to think about is that as you go from left to right, try to think about what questions are you asking, right? And by question I mean like asking yourself in terms of what question are you answering in code. And so for me, let's say our main target is just the main target because I use x in different places, but we construct the prefix sum, we construct the suffix sum. And what is a prefix sum? Prefix sum is just the sum of the first k elements, and suffix sum is the opposite, right? It's the sum of the last k elements all the way back, right? And then from that, I have a lookup table that allows me to look up what is the latest appearance of that suffix sum, right? And why latest? Because we're trying to minimize the number of operations. So the latest is going to be, the closest it is to the end, the fewer addition is from the end, right? So that's the idea between the prefix sum and the suffix sum. I consider them a prerequisite. I am going to go over it a little bit, but if you still have trouble, please go over prefix sum a little bit more. But basically, you know, let's say we have this thing, right? And we have 10. I'm going to go over this case quickly. So we have this case, we have 10. So how do we get 10, right? Well, it's either we take 0 elements from the front and then take the fewest as possible from the right? So the suffix sum will allow us get that by, you know, let's calculate the suffix sum manually real quick. So that's, well, we start with 0 from taking no elements, 3, 4, 5, 25, 27, and then 30, right? So that's our suffix sum. And then now, so then now we take no elements from the beginning. Can we get an answer from at the end? The answer is no. However, let's just say, for example, if our target was 5, the answer will be like, oh, actually we could just take the last 3 elements. So it's just a placeholder for the end. So we could take the last 3 elements. So we update the best is equal to 3, for example, right? So that's, but let's go on with 10. So then now, let's say, you know, now we move the left pointer to one number forward. So now instead of 3, so now our prefix, now our current target is 3, right? So if we take one number from the beginning, our sum so far is 3. That means you're looking from 7 from the end, right? Is there 7 at the end? No, so you can't get an answer here. You go on. So what's the next number? The next number is a 2. That means that if you take it from the beginning, your prefix sum is going to be 5, right? And then what does 5 add to 5? You know, 5 plus 5 is equal to 10, so we're looking for 5. Well, it turns out there is a 5 here, so we can use the 5. And how many numbers are there? Well, we took 2 from the beginning, 3 from the end, so that's 5 numbers. We update our possible answer. And then that's basically how you keep on doing, and step by step, that's how you use the suffix sum to look up that table. And yeah, that's pretty much it. So we have index, which is the number of numbers you've taken from the left, and n minus the latest index that we see on the right, which is the numbers that we're taking from the right. And if at the end, our best, we never touch the best, we return -1 as the default answer. That's all I have for this contest. Oh, sorry, problem. Let me know what you think. And as you can kind of see, this is linear time because for each array element, we only do a couple of linear operation or constant operations, and the linear number of them. So it's gonna be linear time. I use linear space in mine. Let me know what you think, and you can watch me solve it live during the contest now. Dumbness. Exactly 0. Come on. Whew. Wasn't sure about that one. Edge cases. Hey everybody, yeah, thanks for watching. Hit the like button, hit the subscribe button. Let me know about your questions about this problem, other problems, anything. And I will see y'all next problem. Bye-bye.